Okay, I am on section 6.2. I'm going to look at the explain one. It says justifying angle side congruence. So this is our next type of triangle congruence theorem. And it says if two angles and a non-included side, that's kind of the key. Before we talked about angle side angle, and it had to be the included side. Angle side, it's two angles and the non-included side. If those three things are true for one triangle and they're congruent to corresponding angles and non-included sides of another triangle, then that's enough information to prove the triangles are congruent. We're going to go through this proof. It wants us to prove the angle side congruence theorem. So in this problem, we have triangle ACB and triangle DFE. We're trying to prove those two triangles are congruent. They give us the following information. Angle A is congruent to angle D. Angle C is congruent to angle F. And segment BC is congruent to segment EF. Now that right there is exactly what angle side looks like in this problem. But ultimately, they're wanting to show in this problem that we can prove these two triangles are congruent by angle side angle, even though we've already talked about that. So the first statement, I'm going to fill it in. Encourage you to pause the video and try to do some of this on your own as well. The first statement is the given statement, so I'm just going to fill in the missing box. It says angle C is congruent to angle F is what I'm going to put there. And they also tell us angle A is congruent to angle D, and segment BC is congruent to segment EF. All of that is given. Step number 2, it says the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. So of course we know that the three angles add up to 180. You also need to know the reason. It's all about knowing your geometry vocabulary. And that is the triangle sum theorem, is what that's called. The triangle sum theorem. All right, and then it wants us to find the measure of angle B, which of course you've done in previous sections. We know that the measure of angle B is going to be equal to 180 minus the measure of angle A minus the measure of angle C. Step 4, we know the reason is given. It's the triangle sum theorem. So here we're just talking about the other triangle. The three angles, angle E, F, and the measure of angle D have to add up to 180. And again, if we wanted to find the measure of angle E, we would subtract the measure of angle D and the measure of angle F from 180. Statement number 6 says the measure of angle A is equal to the measure of angle D. It also tells us the measure of angle C is equal to the measure of angle F. This simply comes from the original given statement. And there's a number of ways to say this, but congruent angles, because we know all these angles are congruent to each other, have equal measures. So, step 7, think about this carefully. Step 7 looks almost identical to step number 3. See if you can compare those two steps and determine the only difference. The only difference is they've substituted the measure of angle E at the beginning of that equation. Or in other words, And that can be done because of what we stated in step 6. Measure of angle A is equal to the measure of angle D. The measure of angle C is equal to the measure of angle F. So that's the substitution property. And since the measure of angle E is equal to all of that information, and the measure of angle B is also equal to all of that same information from steps 3 and step 7, we can say the measure of angle E is equal to the measure of angle B by the transitive property. Step 9 says angle E is congruent to angle B. And again, that's because angles with equal measures are congruent. And the whole reason for doing this is now we can say, since angle B and E are congruent, we can prove these triangles by angle side angle, because we have two sets of corresponding angles that are congruent and the included side. So that's the reason for step 10. Now, the good thing about this proof is we don't really ever have to do this proof again. The reason for this was to show that, well, if you have an angle side, ultimately you can prove those triangles are congruent by angle side angle. So going forward, we're just going to simply look for the angle side to prove two triangles are congruent. So let's look at the your turn number 5. Couple pages. It says given angle ABC is congruent to angle DEF. So find angle ABC and find angle DEF and know those two angles are congruent. It tells us segment BC is parallel to segment EF. So we know we're going to be using probably some alternate interior or alternate exterior or corresponding angles that you learned in a previous unit in this proof. It also tells us segment AC is congruent to segment DF. So essentially what we have here is we have one congruent angle and one congruent side. So this problem wants us to write a paragraph proof. In this problem, you are given angle B is congruent to angle E. And this is how I'm writing the paragraph proof. I'm saying you are given angle B is congruent to angle E, and you are also given segment AC is congruent to DF. We now need to prove one more pair of angles congruent, and we will use the fact that segment BC is parallel to segment GF to do this. So to find that angle, we have to focus on the angles inside the triangle, right? So look at the leftmost triangle. You have angle A and you have angle C. Which one of those two angles is being formed by that parallel line, by one of those parallel lines? It's not angle A, but it is angle C. Angle C is being formed by a parallel line and a transversal. So that tells me that's going to be the other congruent angle in this problem. And if you notice, angle F in the other triangle is being formed by the other parallel line and that same transversal. So both of those angles are above the transversal and kind of on the underside of those parallel lines. So think to yourself, why are angle BCA and angle EFD congruent? If you said they are corresponding angles, then you're correct. The last part of my proof, I said angle BCA is congruent to angle EFD because corresponding angles formed by two parallel lines are congruent. Therefore, triangle ABC is congruent to triangle DEF by the angle-angle side triangle congruence theorem.